everyone, dear authors and invited guests. It is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and the Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time. Further, with immense happiness, I would like to share that we have received overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers are accepted, contributing to the success of this conference, and the papers will be published in 4 volumes this year. We are thankful to all our guests present on this platform for the conference in this unpredictable times, and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of knowledgeful and interactive sessions. I would like to welcome you to the technical session 7E and further introduce you all to the chair of this session, Dr. Hassan Mahmoud, who received a PhD degree in computer science and technology from the University of Electronic Science and Technology of China in China. He received his Bachelor of Science degree in software engineering from the Shenyang University in Chemical Technology, China in 2011, and the Master's of Science degree in software engineering from Huai University, China in 2016. He is working as an assistant professor with the Department of Computer Science, American International University in Bangladesh. He has published many research articles in reputed conferences and journals. His research interests include machine learning, deep learning, bioinformatics, drug discovery, and pattern recognition. He received a full scholarship from the China Scholarship Council for his master's and doctoral studies. He received the Best Paper Award from the IEEE conference ICCSNT in 2016. And now we can start the presentations with Dr. Yaqing Lu, who will present Howling noise cancellation in time frequency domain by deep neural networks. And the floor is yours. Yaqing, you can start the presentation.
Yaqing Lo, please, you can start your presentation.
Okay, then. Yaqing Lo?
Yes, I'm here, yes.
Please.
Sorry, I had a bit of technical difficulty here. So should I start sharing my...
Sorry for interrupt. Before starting your presentation, I want to mention one thing, that your presentation is for 15 minutes and you will get 12, I think,
it is 12 minutes presentation
and 3 minutes for question and answer section.
Yes,
so
exactly.
Remember, and please remember your time, okay?
I will give her a notice after 10 minutes that she's left with 2 minutes.
Okay,
so don't worry.
Thank you.
Yeah.
Thank you.
Sure, that's fine. Yeah, no problem.
You can begin.
Yeah. So when should I start?
Yeah, now. You can start
okay.
now.
Yeah, sure. Okay. Can everyone see the slides?
Yes, we can.
Okay, sure. Hi everyone. So my name is Yaqing Lo, and I'm the presenter for this presentation. And this presentation is on howling noise cancellation in time frequency domain by deep neural networks. And so, especially for sound reinforcement system, there's always the issue with howling noise. And that happens when the audio signals are picked up by the microphones, which will result in the closed loop system become unstable, and an oscillation would occur, causing the acoustic howling or the acoustic coupling. And this howling can affect the system performance due to the acoustic feedback. And the acoustic feedback would cause the coupling between the loudspeaker signal and microphone signal, which is also known as the Larsen effect. And so it is important for us to suppress this howling noise, because this would be a sound distortion to the original sound signal. So current methods for howling suppression that would involve two categories, mainly speaking. So one is to do with the building structures or the building materials, in which they can reduce the reflection of sound. But this approach is often costly, and also that will require high expertise to operate. Another category of approach is on adaptive filtering, but there are also some issues with those. So frequency shift that will sometimes cause a large distortion to the sound signals. The notch filter-based howling suppression methods is sometimes too slow, like not fast enough to respond with the real-time sound signals. And the adaptive feedback cancellation sometimes is very difficult to accurately locate the specific location in which we can cancel out the sound, in which we can cancel out the howling noise. So in terms for the theoretical analysis, we can see from the diagram on the right that we have the original sound signal coming into the system, which is denoted by VT. And that sound signal would be fed into the speaker, in which it will be processed by using YT. And capital G, that is the amplifier for the sound signal. And then UT is the amplified output, and which it will come out from the speaker. But then sometimes it happens that the output, so through the environment, it will be feedback into the speaker again. And this would form a closed loop system in which the sound would be amplified very quickly. It will start building up infinitely many times, and then it will start causing howling noise. And so you can see from the slides that this process can be expressed mathematically. And also especially for the transfer function, in which it's a ratio between the amplified output, which is expressed as U omega, and with the original sound input, which is the V omega. And in which this ratio can be expressed mainly using G omega, which is the amplifier, and also F omega, which is what's happened when the amplified outputs go into the environment and then being processed in a way. And so when on the right-hand side, so when these two conditions are satisfied, the system will be unstable. So the first condition will be when the magnitude response is greater or equal to 1. And the second condition is when the phase response is equal to n2 pi. And we know that if there's a radio frequency omega, in which both conditions are satisfied, then the acoustic system will produce oscillation at this radio frequency, which can be detected by human ears as howling. So the current challenges for howling suppression methods can cause signal distortion and may not respond quickly enough to the signal changes. And the main methods will mainly would involve adaptive filters in either time or frequency domain. And although they can suppress howling to some extent, but may also lead to sound distortion or limited suppression ability. So for the solutions, we propose a method to suppress the howling noise from speech signal by training deep neural networks as an adaptive filter in time frequency domain. This deep neural network structure would have a higher dimensional structure, and also by using nonlinear activation function, which by using complex coefficient values as the network input can efficiently cancel the howling noise and greatly improve the quality and intelligibility of the processed speech. So in terms for the methodology, so for a commonly used adaptive FIR filter, it's directly using the original sound signal and then process it using a filter. But as you can see from the equations here, that this relationship in terms of the filtering, it's a linear relationship. So which can sometimes lead to limited capability in filtering. So another filter to consider is the frequency. Another filter to consider is the frequency domain adapter. Adaptive filter, in which we would transform the input onto the frequency domain and then do the filtering. But then again, the same problem with this one is that the filtering, you can see the mathematical relationship here for equation 12, that is also very linear, which can limit the capability of this filtering process. So in terms for the howling noise cancellation by the DNN, we would first extract the features from the sound signal by using short-time Fourier transform. And so which we can map the input data onto both frequency and time domains with phase information. So we can see here that for equation 13 that we have complex numbers, and A and B are all complex coefficients. And then we express those complex coefficients in terms of as a vector in equation 14. And then equation 15 is to deal with the boundary condition, in which we will consider the current data point and also 5 points before and 5 points after in each frame to account for the boundary problem. And as you can see for the number 256, that is the width of the frame that we have chosen. So the DNN network, this is quite a conventional structure in which we have the input from the left, from the input layer, and then we have output on the right. And then in between that is the hidden layer in which we will train the data and also to find the mathematical relationships. So the forward propagation can be represented by equation 16 and 17, in which the F stands for the activation function. And back propagation, that is for updating the weight, in which can be denoted by the equations 18 and 19, in which mu is the learning rate. And we aim to find the vectors of weight and biases such that error is being minimized. So for the experimental result, we would have two measurement methods, which are STOI and PESQ. So one is for the speech intelligibility and one is for speech quality. So we can see from the diagram here that in the middle, that is the model by using DNN, but directly using the sound signals on the time domain. So no processing on the original input data. And by using DNN itself can already improve upon the frequency domain adaptive filter, which you can see on the left. But then taking a step forward, so using our method of also involving the complex coefficients. So by by transforming the sound signals onto the both time and frequency domain. So by getting the complex coefficients and then to train using the DNN, we would largely improve the performance of this howling noise suppression. And
2 minutes left.
Yes. And also, similarly, we can see the conclusion from the spectrogram, in which the diagram on the top left, that is the spectrogram for a clean speech signal. And then on the top right, that is when we have a howling noise, in which you can see from the red box and a yellow line. And then, so for the bottom left, that's when we used conventional FDAF. And you can see that the reconstruction of sound signals is not very good. And also we have a lot of energy loss. But then by using the DNN with complex coefficients, so that is the diagram on the bottom right, we can see that the sound signal reconstruction that is almost the same as the original one. And also we can minimize the energy loss. So in conclusion, the howling noise in sound reinforcement system has become a major problem, affecting the system performance due to the acoustic coupling between the speaker system and the microphone when there exists a positive feedback loop. And the conventional methods normally involve adaptive filters in either time or frequency domain, which can suppress howling to some extent, but may lead to sound distortion or have limited suppression ability. So by using a DNN-based method with higher dimensional structure and non-linear activation function, by using the complex coefficients values in the time frequency domain as DNN input features, we can cancel out the howling noise and greatly improve the quality and intelligibility of the processed speech. And also could be demonstrated by the experimental results that the performance of the proposed DNN method can minimize the sound distortion. And that is much better than the conventional adaptive filtering for howling cancellation. Thank you for your attention, and please feel free to ask any question.
Thank you for the presentation. Any questions? Okay, then we will move on to Dr. Ahmed Boumehdi, who will present Arabic speech recognition independent of vocabulary for isolated words. The floor is yours.
Hello, can you hear me?
Yes, we can.
Good. How much time do I have?
12 minutes for the presentation and 3 minutes for questions.
Okay. May I share the screen?
Yes, of course.
Is it good?
Yeah, we can see it.
So, Mr. Professor Yousfi is not here. He was expected to be here at 5 GMT, but it's okay. We can start. The Arabic language is very rich and very complex at the same time, and it is completely different from the English language. It also lacks a lot of data and resources. So my name is Boumehdi Ahmed, and today I'm going to present to you a new approach for speech recognition of isolated Arabic words. This approach will be independent of vocabulary by defining a new phonetic unit that we called semisyllable. We will talk about it in next slides. So this whole work was done by me and Professor Yusfi. So as for the outline of this presentation, I will do a small introduction. I will talk about the challenges that face Arabic speech recognition. I will list some of the previous works on ICR. Then we will talk about the different stages of an automatic speech recognition system for Arabic. We will define, like I said, a new phonetic unit called semisyllable and how it gives a good recognition rate. Finally, I will put a small conclusion and eventually answer your questions. So what is an ICR? ICR, or automatic speech recognition, is a set of methods dedicated to the conversion of a speech signal to a sequence of appropriate words. Automatic speech recognition for the Arabic language is a field that is in current remarkable development, and it still attracts a lot of researchers. This field faces a lot of problems and challenges that we will talk about on the second point. So there are a lot of challenges that face automatic speech recognition for Arabic. The first problem is that the Arabic language is morphologically complex compared to other languages such as English. It contains a significant difference between the spoken and the written language. It also has a lot of dialects. The Moroccan dialect is different from the Egyptian dialect. Even the accent differs from an Arabic country to another. And of course, there is a serious lack of Arabic speech corpora without mentioning the huge vocabulary that the Arabic has. So not a lot of works has been done for Arabic speech recognition compared to other languages such as English. Here we will list a few of the major previous works. So in 2007, Satori and other authors have implemented a speech recognition system for the first 10 Arabic numbers, 0 to 9, on Sphinx. The average recognition rate achieved was about 85%. So in 2010, Abu Bakr and others have developed a system for recognizing isolated Arabic words using neural networks. In 2017, Khalifa and Yusfi have carried out a set of works on the recognition of Quranic sounds by introducing duration as a parameter. So those were some of the previous work done for Arabic language. Let's head off to the different stages of an ICR system. So every basic ICR system goes through these major steps. So we have a speech input that needs pre-processing in order to get rid of irrelevant information and keep only the relevant one. After that, we extract some numerical values from the signal. It's like the signal should be represented by a matrix that contains all the information about the signal. And at the same time, we know this matrix corresponds to a certain combination of words or syllable or phonemes or semisyllables or whatever. There are a lot of extraction features, methods such as PLP, MFCC, LPCC. So in our case, the MFCC was used, and it's the most used one. So after we extracted the features from signal, it comes the step of training and modeling. A model can represent a word, a phoneme, a semisyllable, etc. The goal of this step is to build models. Every unit should have a model after this. After constructing the model, we should have the prediction step in which the system should be able to recognize models, or in other words, to recognize spoken units. So in our case, like I said, the phonetic unit was called semisyllable, which is something new. So this table represents the simple standard Arabic letters and their corresponding codes. So what is a semisyllable? A semisyllable is a combination of a simple Arabic letter and its diacritic information, or as we call it, a shakl in Arabic. So for example, the letter B or ba, all the possible semisyllable units are shown on this table. And this is an example of a conversion from the Arabic word wasala, or in English to arrive, the verb to arrive, into the semisyllable form. So as you can see, we defined a new phonetic unit, but the problem is that we don't really have a database consisting of audios and their corresponding semisyllable form. So we had to do it by ourselves because, like I said, there is a lot, there is a lack of Arabic resources on this field. So for the database, the recordings were done by a single speaker using one single computer and one single microphone. The number of recordings was 1,711 words, which were split into two groups. 1,500 words were dedicated to the training phase, and 2,011 words were dedicated to the testing phase. Each word from the training corpus was manually cut into semisyllable units. The feature extraction method used was MFCC, like we said. We used the 13 first MFCC coefficients and the first and second order derivatives of these 13 MFCC's coefficients for each semisyllable unit. This is in order to extract the features. A 5-stage architecture of hidden Markov models was used to build the model, of course. After training and constructing the model, the recognition rate achieved was 82%, and the recognition rate achieved on training set was 93%. Most of the phonemes or syllables were recognized with on almost 10%, 100%. The errors observed were mainly due to the fact that some Arabic phonemes are very similar in terms of their pronunciation. For example, the letter sin and the letter sad. The recognition rate can be enhanced in future works by adding more records to the training set, or adding more parameters on learning phase like duration or power, making the number of states a variable that depends on the phoneme, making a semisyllable depending on its position in a word. So on this presentation, we listed a few significant works that have been done in the past few years. We also reviewed the basics of speech recognition system and the different stages and approaches used to build an ICR system. We also introduced a new approach for Arabic isolated words that is independent of vocabulary and that helped us build an efficient ICR system with a good recognition rate. Thank you.
Thank you. Thank you for the presentation. Any questions? Okay, then we will continue with Dr. Bayar Shahab will present an efficient approach for multiple moving objects tracking with occlusion. The floor is yours.
Hello, thank you, Mohammed. Let me just share my screen.
Yes, we can see your screen now.
Okay, perfect. Fine. Hello, everyone. So my name is Bayar, and I'm currently a PhD student in Ronto Vergata University. This work actually was a couple of years ago, was my master's research, an efficient approach for multiple moving objects tracking with occlusion. Now, object detection and tracking has been used since firstly the CCTV cameras has been introduced, and after that it got more popularity and lots of different models and algorithms came into the play to detect and track the moving objects, specifically in a video camera. Now, in this particular research work, we are actually more focused on the tracking of the moving objects in a surveillance video. We have used the Kalman filter-based approach, and we have tried to optimize and enhance the original Kalman filter to track the multiple moving objects in a better way while they are occluded. By occlusion, we mean when the objects are actually not seen or they are being blocked by any barrier. Let us say you have an object that's moving and suddenly it's hidden by a wall or something. So that way we need to track and predict and estimate the location of this object. Now we have done an extensive literature work from the simplest to the more complicated one, from the oldest to the most new ones, and we have actually introduced new categorizations for object detection and then object tracking as well. And the literature part of this work is already been published in IEEE conference. For those who are interested, they can always refer to the published literature review of the same work, where we have done lots of analysis and evaluations between the different methods that can be used for detection and tracking. Now, the main goal was to actually detect and track the multiple moving objects in a video while they are fully and partially blocked or occluded, let's say. And the second objective was, which fortunately we have achieved as well, was when the objects are merging and splitting in a video to actually be able to track them. Now, the theoretical backgrounds behind this work was for the detection we have used MOG, mixture of Gaussian, which is a background subtraction method. We don't have much involvement in the detection part. We just have used and done lots of research to choose the best method. While for the tracking, we have tried to improve the basic Kalman filter method, and definitely we have used some image processing tools and functions to support the processing and post and treatments of the things. Now, this is a basic basic system design where we detect the objects and then we do some post treatments and then we label the objects. And finally, we assign the detected objects to the trackings, where we track them all the way through the video. As I mentioned, we have used MOG for the background subtraction. And what we have done here is we have tried to use an adaptive MOG method in which you actually find the background model and then update it in each iteration of the process, so that you make it so dynamic and adaptive all the way when the video is being tracked. These are the mathematical concepts behind the emoji, which I'm not going to go through it. Now, the object tracking is where we have the most of the contribution, in which we have used an enhanced based version of Kalman filter. Basically, Kalman filter is trying to estimate or predict the location and velocity of an object when the measurements used to measure these quantities are actually not certain, or there are some errors in the prediction. Let's say you have an object, just like I explained it, moving, and suddenly it's been blocked, or it's been hidden by something, a barrier, a wall, or anything. This is where you have some errors, and that's how you need to solve this error. And in a typical Kalman filter, you have basically two steps: prediction and correction. Prediction is to predict the location of the object using the previous frame and the velocity of the object. And usually there are some factors affecting the prediction. Let us say you have some noise, you have some wind, you have some shadow. These can all affect the prediction of the tracker. So occlusion is one of the issues, one of the errors that's affecting the prediction. So and it's called motion noise. So we have tried to improve this motion noise. This motion noise is usually a fixed constant value that compensates between the predicted value and the actual value. So it's fixed and constant. We have tried to make it adaptive. We have tried to decrease this motion noise in every step of the algorithm, so that this motion noise can get decreased in each step, and finally it will lead to the Kalman gain, which is the main factor of the predictor, to decrease. And once the Kalman gain is decreased, then the algorithm is actually putting more trust into the tracker rather than the detector. And that's what we are trying to achieve, because if an object is not being detected by a camera, then you need to actually trust the tracker more than the detector. And that's what we have been doing, and that's what we have been achieving. We trusted more the tracker rather than the detector, because the object is actually missing from the camera. And after that, once we predicted the actual location of the object, then we correctify the location, and we say that this is the correct location that's been predicted, even if it's hidden and not shown by the camera. And then we update the variables, and then we move to the next iteration. Now we have used a couple of challenging data sets. These are public data sets, the first and the second one. And the third one is actually a video from the MATLAB directory. And the last one is our own experiment or videos that are recorded. Now we have three test scenarios. The first two are actually object tracking having full occlusion using two different data sets. The third one is while they are partially occluded, and the last one is when the objects are actually merging and splitting, and then we are checking if we can track them correctly. Now for the performance measurement, we have used the common famous Euclidean distance to find the distance between the detected centroids of the objects and the predicted centroids of the objects. By centroid, we mean the center of the object. And once we do that, then we compute the percentage change or improvement between the original algorithm and the improved algorithm to find the improvement rate between two algorithms. Now, this is the result of the first test scenario. We have observed 100 frames. The reason we have observed 100 frames is because this is where the object is being blocked by something. That's why we didn't actually observe the full frames of the video. The first one is a video from the MATLAB directory, and then the number of frames we could improve successfully were 52, and the sum of percentage of improvement 21. And on average, we have 0.41 improvement for the first algorithm or first.
2 minutes left.
Sure, yeah.
Sorry for the interruption. 2 minutes left.
Sure, yeah. This is the result. You can see an object is being occluded by a tree. In the left side is the original algorithm. You can see it's not predicting it correctly. In our algorithm, it's actually predicting it in a better way. Now, this is the second test scenario. On average, we have 0.56 improvement comparing to the original algorithm, which is from a famous data set of eyelids, bag, and vehicle detection. And this is, you can see the object from the black and white will be detected by a wall. And the original algorithm is actually detecting the leg of the person, while our algorithm on the right side is actually detecting the object or tracking the object, sorry, in a better way. And this is the result from the third video, which is 0.5% improvement comparing to the original algorithm, which is our own recorded video. And this is, you can see the object is partially occluded, and our algorithm on the right side is predicting the location in a better way. And this is where the objects are merging and splitting. Our algorithm is actually tracking the objects when they merge and split, while the original algorithm is failing to do that. Now, on average, we have 0.49% improvement comparing to the original Kalman filter algorithm. We have actually some limitations and future works that can be carried on, which is real-time analysis and using a better camera quality for the research. And the limitations we have had is the weather conditions, the dark environments, the bad lightings. These were all the limitations that we have suffered from. And that's it. Yeah, thank you.
Thank you. Thank you for the presentation. Any questions?
Okay, I want to ask the questions.
Yes, of course.
Okay. So actually, which algorithm you used in your proposed method?
The algorithm is Kalman filter based approach, and we have tried.
Yes.
Yeah. And we have tried to improve some parameters that are making the Kalman filter very adaptive in each iteration, so that it can.
Right. Okay.
Yeah.
Okay. So actually, I see in your slide that you mean you wrote a original algorithm. So what was that algorithm? What do you mean?
The original,
yeah, original one.
Yeah, the original algorithm is Kalman filter based algorithm.
Okay. You just tuning the parameter for iterations.
Yeah, a couple of parameters we have fine tuned it to make it more adaptive and predict in a better way.
Okay. Thank you.
No problem. Welcome.
Thank you. Any more questions? Then we will move on to Marwa Al-Arini will present character recognition from images using a convolutional neural network. The floor is yours.
Hi everyone. Can you hear me?
Yes, we can hear you and we can see the slides.
Okay. Good evening everyone. I am Marwa Kamel from Bisha University. I am Palestinian, by the way. On behalf of myself and Dr. Fatima Al-Hafiz and Sheikh Ammash, I would like to thank you for this wonderful opportunity. This evening, I would like to discuss and present our project character recognition from image using neural network. And the outline as a follow. Introduction, then we will talk about the general structure of CNN, the most common existing method in the same application, the architect of proposed CNN model, then our experiment result and discussion. With the emergence of a smart device that can come into contact with and understand environment using computer vision techniques such as robot, smart camera, and self-driving car, optical character recognition is a vital tool that should be embedded. OCR is the electronic translation of handwritten, typewritten, or printed text into editable text. The main goal of OCR operation is to convert hard copy, document, or image into soft copies that a computer can read and use for many purposes, including information retrieval, text analysis, data mining, cross-language retrieval, and machine translation. With OCR, the error rates in the process of converting paper document into digital are minimized, and Word can be easily found, especially in large files. There are many issues that could affect OCR accuracy, such as the lighting condition of the image, the use of font with different size, and the angle and focus of the camera. Now, how does the general structure of CNN looks like? Basically, the CNN is a common form of deep neural network capable of extracting features and classifying character with a high accuracy and low dimension. The hidden layers of CNN typically consist of series of layers. The first layer is convolution layer. This layer performed an operation called convolution. Convolution uses the filter or kernel that moves over the entered matrix of data to produce an output. As you can see in figure 1, describe the convolution operation. The kernel, the yellow square, moves over the entered data, the green square, and the sum of convolution produce the feature map, the blue square. Another definition is important, which is padding, is the number of pixels added to an image and set to 0 value when it is being processed by the kernel of the convolution layer, as you can see in figure 2. The second layer is a pooling layer where allocated in between CNN layers. The main aim of pooling is to constantly reduce the dimension of the matrix. As you can see in figure 3, there are several types of pooling, but the most popular one is max pooling, which selects the maximum element in each region of the feature map. Yes. At the third layer, there is a need to convert a 3-dimension of data to 1 dimension for a classification process. Because of the fully connected layer, only 1 dimension or of data can be accepted. The last layers of CNN are fully connected layer, which is basically the simple neural network. Now with the most 3 important CNN model, alt next applies a rectified linear unit as activation function and uses dropout. Butalib et al. Compared a multi-layer perceptron with CNN in MNIST dataset. They achieved accuracy of 89.47% with the MLP. Moore et al. Developed a handwritten letter classification as application on Android operating system. They achieved a high accuracy of 87.1% over MNIST. As you can see in figure 4, our proposed model consists of 5 convolution layers. As we can see, as a typically CNN model, the first layer is convolution layer, 2-dimension. It deals with the entered image, which are considered as a 2D matrix by using conv2d function that accept 5 parameters. The first parameter is the number of filters in each layer, in which we used 64 for the first and second convolution layers. For the third, fourth, and fifth convolution layer, we used 128 filters. Second parameter for padding, we used the same. Third parameter, the kernel size is 3 by 3 pixel at time. Fourth parameter, which activation function we use after each convolution layer. For CNN, the ideal activation function used is ReLO. The last parameter is the input shape, which determines the pixel size of the entered data. And between each convolution layer and max layer pooling, we use batch normalization to simplify the values of feature and make the computation faster. Next, max pooling layer. With a pool size of 2 by 2, we dropped 0.3 of neurons to avoid overfitting, and overfitting is one of the most important problem may face us when in a training time. then added a flattened layer, which takes the output of the 5 convolution layer that we built and transform it into 1D that can be used by final fully connected layer. Lastly, the dense layer is added to generate the final reproduction. The dense function accepts 2 parameters. The first parameter is the number of output node, which is 47 in this model, since we aim to generate a prediction for 10 digits and 37 lowercase, uppercase letters. Second parameter in which type of activation function we use for the output layer. We use softmax as a multi-class classification. The architecture of the neural network and the size of dataset are the main factor that should be considered carefully to achieve better accuracy. The architecture of neural network refers to the number of filters and their size, the type of convolution, the size of pool in the max pooling layer. The stride number have the same task for both filters and pool, the number of epoch and batch size. We used the MNIST dataset, which is a set of handwritten character digits derived from the large dataset known as the NIST. To evaluate this model, we used MNIST balance, this category, because there are 6 categories, which contain 131,600 characters across 47 class, as well as digits from 0 to 9, lowercase letter from A to Z, and uppercase letter A to Z. The experiments were conducted in Python 3 programming environment with Jupyter Notebook Anaconda 2020.07. The experiment was performed on a 2.90 gigahertz Core i7 PC with a 12 gigabyte running on Windows 10. The result of the first experiment shown in Table 1 present a number of iterations, the training, cross-validation, testing accuracy, and the loss function for different batch size. For a fixed learning rate, which is 0.01, it shows that a better training set, cross-validation set, and test set classification accuracies are achieved for batch size 32. For the learning rate 0.01 after 3,525 iteration for the training set and 293.75 iteration for the cross-validation set. On the other hand, the learning rate is also an element that affects learning. An experiment was conducted to observe the effect of the learning rate on the performance of the proposed CNN model. Table 2 shows the training, cross-validation, and testing accuracy and the loss function for different value of the learning rate for a fixed batch size 32. After 3,055, sorry. Yes.
2 minutes left.
Okay.
Sorry for the interruption.
Okay. In Table 3 compared the outcome of a proposed method with those of the related works, which mentioned before. It is notable that the proposed method has shown competitive performance via a vice existing method in terms of test set accuracy. It used the largest dataset compared with the other. Furthermore, the proposed method is configured in a local CPU with a reasonable time of around 90 minutes compared with the around 2 days to 1 week for other method. Yes, so we can see say that CNN are improved. Thank you for attention and sorry for late. And any question, I will be happy to answer.
Yes, thank you. Thank you for the presentation. Any questions?
Okay, I can ask the questions to Marwa, Dr. Marwa. So, why used CNN instead of other machine learning algorithm?
Because it is considered because it is sometimes it is look like it is a special for character recognition.
Okay, so you are working with text data, right?
Yes.
Okay, so I have seen you compared your model with two other methods, and one the first method showed 92-point accuracy. So this method is better than your method. So why your method is not achieve more than 92%? In your last slide, the comparisons.
Yes, yes, I understand.
Okay, it's okay. It's okay.
Are there any questions?
Maybe because the dataset, yes, we used there used other dataset.
Okay, it's okay, Dr. Marwa, but I think it's better to if for comparisons, better to use same data sets with other model. Okay,
Okay.
then we'll get the real prediction. Okay, thank you. Thank you.
Thank you.
Thank you, Doctor. Now we will move on to Dr. Iqlal Shitin Tas will present image decomposition for helping diagnosis of COVID-19 lung injury. And the floor is yours.
Can I start?
Yes, of course.
Okay. Can you see my presentation?
Yes, we can.
Okay. Hi, everybody. Thank you for your attendance. Welcome to my presentation. I want to mention some information about my papers. My paper is the image decomposition for helping diagnosis of COVID-19 lung injury. Outlines, introduction, materials and methods, application and results, conclusion, and references. COVID-19 pandemic has affected the whole world and continues to affect generally. This disease detects with the PCR test. Mostly symptoms of this disease similar to seasonal flu, and lung problems related to COVID are common among the patients. Lung injury are the most critical symptoms of COVID. Most of the patients die from the lung problems. Because of these reasons, biomedical imaging methods are essential for the diseases. In the diagnosis of many diseases, X-ray and CT monitoring methods often used for the diagnosis duration. Biomedical image processing methods provide convenience for disease diagnosis. Many methods are applied, such as filtering, segmentation, decomposition, and reconstruction. One of the most popular ways is wavelet transform, is the type of the frequency analysis method. Wavelet are the mathematical functions that subdivide data into its frequency components. You can see in this slide our methods flow chart. Firstly, we read the sample image, and then we apply the wavelet decomposition and thresholding, and the third step, wavelet reconstruction, and the last step, we apply the morphological operations is related to segments. In this paper, wavelet is tried to find the frequency band and desired components on the chest X-ray image. This figure provides us the many studying possibilities. Then the approximation is divided itself into the second level of approximation and detail components. At the last stage, morphological operations are used to eliminate undesirable part and reveal to target regions more clearly. This study is aimed to find out the best result for detection lung disease region by using aforementioned technique. We use the data set includes both chest X-ray and CT image. These images belongs to either COVID-19 patients or healthy persons. We choose the samples among the patients COVID-19 X-ray randomly. In these studies, we use the wavelet packet decomposition and reconstruction. The wavelet packet decomposition are at the same as the wavelet. We can decompose the signal into low and high frequency components by using two ways. These are the wavelet decomposition and wavelet packet decomposition. The significant difference between these ways in the wavelet transform works with only the low frequency components at next levels, while the wavelet packet transform can work to both low and high frequency components at each level. Hence, wavelet packet decomposition result can give better results for the high frequency applications. In this study, two-level wavelet decomposition tree is used. Dabishi's wavelet is chosen the wavelet type. You can see in this slide subband tree schema and four-level wavelet decomposition schema. This is the horizontal, vertical, and diagonal parts. This is the tree decomposition tree. At the last stage of our applications, we use the morphological operations. These are the im-delete, im-erode, and im-clear borders. Morphological operations are wavelet decomposition and reconstruction processes for distinguishing the disease region. You can see in the slide one of the sample image for our works. This is the second one. You can see the marked regions, disease regions, the marked regions by our radiologist. Firstly, our radiologist marked the COVID injury regions in terms of the reference point for this study. The chest X-ray images for the data set are chosen randomly. Our first step, we read the sample image and wavelet decomposition are applied. 20 terminal nodes are built in this way. The terminal node number is related to the decomposition level. Decomposed image at two-level Dabishi's four wavelet packets using with the sure entropy for the thresholding. We can explain the differences if only approximation sub-image can decompose, it is called the just wavelet transformation. Each terminal nodes, you can see in this slide, is segmented with the common thresholding. Decomposed images are separated into 6 segments by implementation of the thresholding. We use the sure entropy for the thresholding. And then reconstructed all the subband reconstructed segment is investigated. And the reconstructed parts are segmented, separated the segments and Third segments include the COVID region, and morphological operations are applied for the detecting this disease region clear on this segment. At this stage, we have been able to eliminate the border point determined by the other applications. You can see in the slide the result images for sample 1 and for sample 2. The resulting image is examined and lung disease region is approximately marked by our radiologists. The segmented regions may assist the health personnel in the moment of decision. As a result, these methods have been found to be successful in detecting disease regions. In future works, the new wavelet model can be designed for the segmentation and increasing the wavelet frequency analysis performance and maybe its performance compared to the traditional wavelet types. It can contribute to the different segmentation methods, such as k-means, region growing, which are used to detect target regions more clearly. This type of the applications on chest X-ray image can be examined for following the spread of the damaged regions during the disease. This is my references. Thank you.
Thank you. Thank you for the presentation. Any questions? Okay, then we will move on to Dr. Temitope Mapaye will present multi-scale fuzzy entropy approach for vascular network delineation in retinal images. And the floor is yours.
Good evening, everyone. I will be sharing my screen.
Yes, please.
Thank you so much. Thank you so much, everyone. I am Temitope Mapaye. I am presenting this work, multi-scale fuzzy entropy approach for vascular network delineation in retina images. I am my co-author. My co-author is Pius A. Olawi. This is the outline of my work, the background study. Then I will talk about the open research problems in the field. And then I will talk about what I am actually addressing and the methodology I'm using to address them. And also I will talk about the experimental results I obtained from the methodology I used in this study. Also, I will talk about the performance comparison of the results I achieved with the existing results in the literature. And then I will draw my conclusion. Okay, basically, I will be talking about, I will be giving a background study of the retina fundus imaging. It has a lot of applications in the field of ophthalmology and even in the field of biomedicine. And basically, the retina is an open way to actually talk about the state of health of individuals. We use, in the medical field, biomedical field, the anatomical structures in the retina images are used to actually determine the state of the health of different, of people or of patients. And from the retina, you can actually, it's a point where certain different diseases are actually detected, like cardiovascular diseases, like the high blood pressure, like diabetic retinopathy, like retinopathy of prematurity, also like the malaria retinopathy. Basically, when these diseases are not yet evidently seen by people, the retina can be an access point where medical experts use in determining the state of the health of individuals. In my next slide, I talk about the different diseases that can actually be detected using the digital retina imaging. We have glaucoma, which is, it can assist in the early detection of glaucoma, really, and also prevent a permanent loss of vision if the disease is managed early enough. So the early detection and early management can actually stop or can actually disallow the issue of vision loss. And also we have what we call the age-related macular degeneration. We have retina detachment. We have diabetic retinopathy. And the diabetic retinopathy is one of the diseases. It's one of the major causes of blindness globally. And it's actually linked with diabetes. So, and the anatomical structures of the retina are actually used in it. One of the good example of the anatomical structure used in this point is the vessel, or you call it the blood vessel, or you call it the vascular networks. And also the high blood pressure, also you can actually detect that from the blood vessels in the eye, which could be the vein or the arteries. But when we talk about the glaucoma, you can use blood vessel. We also use what we call the optic disc and optic nerve. So, and cancer also, which is what the dark spots also in the retina, could be an assist in detecting signs of cancer in the body. So I try to show some images here, but basically globally, the experts, ophthalmologists or experts who are actually in the field of digital retina imaging, like ophthalmologists, they are few. And due to the inadequate skilled staff to manage the increase in patients, we know globally the rate at which humans eat fast food and some other issues contribute a lot to health situations of humans globally. And also the time consuming manual, the time consuming of manual blood detection is also another issue. It could be boring to the experts. And also, aside from that, it takes about, according to research done, averagely it takes about 2 hours for the experts trained to actually delineate or detect the blood vessels or the vascular networks in one retina image. So that is a lot of time. So, and we know efficient detection actually could help in efficient analysis so as to help in diagnosis of diseases. So, and we know also that inefficient analysis of the network and other retinal anatomy structures could also lead to poor diagnosis. I actually put some images here. The main images are here. We can see the first image. Maybe I can just enlarge it a bit for clear view. We can see this. We can see the blood vessel. It actually talks about the different a normal retinal image, and we can see the different anatomic structures here. And also in the second image, which is the B image there, we can see the blood vessels, but there are differences in the blood vessels in the second image, which is the image in B and the image in A. The image in B actually have some tortuous, and according to Richards, tortuosity is one of the major characteristics. When characterizing vessels, tortuosity is one of the issues that can actually talk about the state of health of individuals. Good enough or clear enough, tortuosity is one of the signals of diabetic retinopathy. It's one of the signals of high blood pressure in the blood vessels. And once it leaves, though this image seems good and healthy, but an expert knows that this is not good enough for a patient. And if it leaves the stage, which is not actually, you can't actually say these diseases are not actually evident to individuals, it could lead to the third stage where there are block leakages in the blood vessels there. But before it gets to this stage in C, it is better to manage it early. It will be better to manage it early enough before you get to the stage. And after this point, it moves to this point where we start seeing different spots on this cotton wool spots, and before it degrades to this. The essence of this research is efficient detection of the vascular networks, which will actually aid in the efficient analysis of the efficient characterization of the vascular network itself. There are open research in this field. Basically, one of the key research, open research, is still the improvement. There's a need for improvement in the detection of the blood vascular networks using machine learning techniques. Though existing research have done that, in terms of supervised techniques, the supervised techniques achieve good results, but in terms of training, once you move from one data set to another data set, it will take some time again to actually get features from those data sets, such that after getting the features, you might not be able to use the features in data set A to actually detect the blood vessels in data set B. That is still a major issue. And in terms of unsupervised techniques, also, though it can actually go through the images through after using some patterns therein to detect the blood vessels, but it's not as efficient in the detection of blood vessels as compared to the supervised techniques. And also in the characterization, there are still rooms for improvement in terms of the characterization of the blood vessels or the vascular networks. Basically, I am focusing, this research actually focuses on the blood vessel or vascular network detection. So I will use the word blood vessels or vascular networks interchangeably in the course of this presentation. So the study contributed by investigating the use of fuzzy entropy-based approach or based on the differential evolution segmentation method, but it uses a multi-scale approach. Though that segmentation approach is an unsupervised technique, but it uses a global thresholding approach. And in terms of blood vessel detection, global thresholding are inefficient. They are inefficient according to research. And due to the fact that the characteristics of the image, they are uneven illumination that actually affects the image of fundus images. And also there are variations in the blood vessels widths. So due to this, a global threshold might not be able to actually detect the blood vessels efficiently. And according to research, global thresholding techniques are weak. So we have to use a multi-scale approach. How do we do that? But I will talk first about the fuzzy entropy-based on differential evolution method, which is we have to actually use the technique that applies fuzzy partition of the image to an image histogram while obtaining the entropy measure. And in order to actually obtain the optimal fuzzy entropy threshold, we used a differential evolution method, and the algorithm is presented in the next page. And the multi-scale approach is that in our pre-process, when we actually did we performed difference imaging on the retina vessels, on the fundus images, the grayscale of the fundus images, or the fundus images. And we performed it across different windows, 9, 11, 13, 15, 17, 19, and 21. Though these were actually chosen based on experiments. So after that, we applied morphological opening to the results obtained from these images. And then we aggregated the results obtained from these images to obtain our final result. This is the algorithm for differential evolution. And then this is the result obtained. These are the fundus images in this image. These are the grand truths used. These are the results of the proposed techniques. Here, that is the fundus images A, B, C, the grand truths, D, E, F, and also the result obtained, G, H, I. And this is the table of the results. Existing results in the literature, this is the proposed technique here. We achieved an average sensitivity rate of 73.20%, average accuracy rate of 95.91%, and average specificity rate of 98.10%. And in conclusion, we've been able to present how effective a fuzzy entropy-based differential evolution segmentation that has been aggregated using a multi-scale approach across different windows. We investigated that and we observed that it actually presents a promising result when compared to the existing results. And when we did our work, the average time this technique requires per image is 46 seconds. actually, as compared to the 2 hours of manual approach and existing supervised techniques also, which actually requires more time. And besides, this technique does not require training. It uses an unsupervised approach to achieve that. And in our result, we were able to detect the large vessels and to a certain level, the thin vessels in the retinal fundus images. Thank you for listening to us today.
Thank you for the presentation. Any questions?
Okay, and to ask a question.
Yes, of
Can
course.
you please go back to your slide number PPT 10?
Number what, please?
10.
10, okay.
Yeah, 10. Okay. I can see here your proposed method achieved accuracy is 95.91%. So it's a
yes,
good result, and compared to better than, we can say, others method. Okay, so
yes.
how about CV cross validation? Have you used any cross validation during or cross validation?
Okay. Not yet. Basically, we actually compare the database we use, that is the drive database, really, actually is available online. And on the drive database, different algorithms proposed are tested on the database. So we use the database and the ground truth presented online on those databases to actually do the benchmark. And the comparison, the testing approach, it's a pixel to pixel, because sometimes vessels may seem present and sometimes it might be bigger because we are actually after the width, the accuracy of the measure of the vessels. So we use the benchmark on the side, on the available database for our work. And we compared what we achieve with what other people have actually said in the literature by doing the same thing on the database.
Okay, actually, I'm talking about the cross validation, because you can see here sensitivity, accuracy, and specificity or specificity. Okay. So for this metric, actually, we need to cross validation, actually 5-fold, 10. Actually, for cross validation, fast cross validations. For the cross validations, maybe if you use 5-fold cross validation, your data set will be separate in the 5 parts. Okay, and then you will get every time 5 results. Okay, first 1 result, and it will be averaged by your results. So it will be more. Maybe next time you can maybe follow that rules to verify.
Noted.
Okay, thank you. Thank you.
Thank you so much.
Thank you.
Thank you.
Any more questions? Well, I sincerely thank our authors for their excellent presentations and contributions in these sessions, and all our participants for being a part of this international congress. I hope this session was informative and knowledgeable as well. All the presenters would be getting their digital certificates through mail within 2 working days. Further, all the papers have already been forwarded to Springer. The publications will be live within 4 to 6 months. Kindly cooperate with the team of ICICT 2021. I also thank our session chair, Dr. Hassan Mahmoud, for chairing this session. A token of appreciation to the chair on behalf of Team ICICT 2021 and Global Knowledge Research Foundation. Thank you all, and I kindly ask you to put on your cameras for a quick snapshot for the virtual conference, please. Thank you all. Take care and stay safe. Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.